Hey guys, this is Swati and you are welcome to my YouTube channel Big Data Online School. As discussed in previous videos, we have seen the Unix architecture, features and the history and some of the codes in Unix. So to proceed with this session, we will be going to see Hdfs command. Since we have already seen theory of Hdfs, like what is the architecture, features and characteristics of Hdfs. Hdfs is nothing but it's the heart of our Hadoop system. So today we are going to see Hdfs command. So let's get started. Since we have already set up our cluster here, so we are going to run commands in live only, and we can see. So in order to create any new directory, we have already seen like mkdir is the command that is used to create a new directory. But to create a new directory in SDFS means Hadoop, we have to write like Hadoop fs minus and then mkdir dir and then giving the like path name. So I'll show you. Since we are going to create file testing as a folder, so we have put hadoop fs minus mkdir, and if we are going to check like if it is created or not, so we can put like hadoop fs minus ls. So we will see that testing folder is already created. See here, it is already created since we have created it right now. So if we want to delete it, maybe if we have to delete this file, so we can use the same, like instead of mkdir we have to use rmdir. So we have deleted this file, and if we are going to see with the ls command, we can see that this testing file doesn't exist now. See here, testing file doesn't exist now, but previously it was there, right? Let me okay. Yes, if we go for the next command, if we have to check whether the directory is created or not, let me tell you, like the whole of the path is like we go for absolute path, we have to go for /user/sd user. This means that this path is nothing but Hadoop's path, which is a virtual path where all the like metadata is stored in name node. So if we put like this means we are putting absolute path. Okay, and we can see what are the directories and what are the files are created under our Hadoop system. Next, we'll be like putting our file from local to Hadoop system. First of all, let me explain like in Hadoop. Actually, Hadoop is not for like OLTP kind of system, which is be going to updated or maybe modified very like frequently. This is generally for OLAP system, which is already done, and we are just maintaining data. So for this only, we are not allowed to use like VI here. As you know that we generally used to do VI in our system, local system means our Linux system, and then we used to create any file and we write like we use VI editor mode, and then we used to insert anything, or maybe like we used to give command. But here in Hadoop, we are not allowed to use VI. It's because it's not suitable for OLTP system. It's only suitable for OLAP system. So in order to put anything in Hadoop system, in order to write anything in Hadoop system, we are not allowed to write here. So what we can do, like we can do some modifications, some changes in our local system, and then we can move, or we can copy the data from local system to our Hadoop system. We'll see here. See what we are doing is, first of all, this cd till command means that we are going to be there in our home SDuser path. So since we are already in home SDuser path, I'll show you. See, we are already in our home SDuser path, so no need for that. Next, we are going to echo this test data into a test.txt folder. This means that it will create a test folder where test data will be echoed. If we see this test.txt, we can see that test data will be there. See, this test data will be there. Okay. Now what we are going to do, we are just copying this test, like we are just going to copy this. Okay. First of all, let me create one testing folder since I have already deleted the testing folder. Yeah. Now what we are doing, we are copying from local of this text folder to the user testing folder. This means that this test.txt which has data as test data, this will be copied to our as the user folder in testing folder, and we can see the data in Hadoop now. We are moving our data, like we are copying our data from local system to our Hadoop system. You can see here, like we have done like Hadoop fs minus copy from local and from test.txt to user as user and testing. Okay, now if I'm going to check this testing file, we can see test.txt data everywhere there. This is the absolute path that we have given, and we can see that this is under test.data, like this test.data is over here. Or if you want to find like whether that test.txt file is there or not, you can just put ls. See, under testing folder, we can see a file that is nothing but this test.txt that we have just copied from our local system to our Hadoop system. Okay, this is nothing but file which has these access list, and this is the owner, and this is the group owner, and this is the time creator, and it has a file size of byte 9 like bytes. Moving to next part, like if you have to view the content of the copy file that I have already checked, like if you want to see whatever there in test.txt file, we can just cat this file, and we can see what are there inside this file. Just now we have seen, right? That is test data should be there. See, test data is there. Like this we can see, and also if we want to remove this directory, yeah. Next one thing is like suppose if we have to remove this testing file, testing folder, okay, and if we generally what we used to do, generally we used to write Hadoop fs minus rm and then user testing, but it will not allow to move this testing folder. Why? Because under testing we have test.txt file also. So in order to move this like testing folder, we have to put like rm minus r. This is because we have to remove directory recursively. Hope you guys are getting it. So if we do like this, minus rm minus r, so see what message it is showing. It is deleted testing folder. Now if we are going to check whether testing folder exists or not, you can see that testing folder is not there anymore. See, you can see from here testing folder is not there anymore. No testing folder exists right away. Yeah. If we see the next command, it's like move file from local to Hdfs. This means that previously we have copied our file, right? Yeah, now we are going to copy our file. This now we are going to move our file. Like previously we have moved our file, sorry, copied our file. Now we are going to move our file. So the difference between copy and move is like, if we copy anything, this means that the file is only copied from local to Hdfs. Like it is not going to be vanished from local system, but if we are moving our file, so it means that we are just taking that file from local and putting it into our Hadoop system, and after moving there will not be any data, there will not be any file in local system. Let me show you this. See, Hadoop fs minus move from local. What we are going to move? We are going to move this test.txt. Let me show you this test.txt is there in our local system or not. Yeah, we have, and this under this test data is present. Now we are going to move this test.txt into user as user. Okay. Now if we like perform this, like if we execute this command, you will see that after executing we will not be allowed to see this test.txt in our local file. See, now data has been moved. You can see like if we go for Hadoop fs minus ls, you can see this test.txt exists here, right, which is of 9 KB, and if you want to see like what is there inside this, you can see. See, this test data has been moved into Hadoop Hdfs system. Now if we are going to see this test.txt is present in our local system or not, that won't be there, as we have discussed now. See what it is showing. It is showing as no such file or directory exists. This means that we have moved the whole of the content from local system to our local system, from local system to our Hadoop system. Okay. Now the next thing is appending files from local to HDFS. Yes, we can append files. It means that suppose if we have in test1.txt we had test data, right? But if we are going to append something into this test.txt, we will be able to do in Hadoop system only. Though we are not able to write anything, but we can append something. This means that we are not going to alter our existing data. We are just adding some of the data, right? So let me add one something into my one new file, test1.txt. I have just added some data into into my file that is in local test1.txt. Let me show you here. See, some data is present in test1.txt. Now what we are going to do, we are append to file this test1.txt. Whatever is there, that is some data under that, we are going to write it into our test.txt only. That means that we are going to append into some new lines. This means that the existing data won't be like destroyed, or that won't be altered. Just we are going to append new data. You can see now this under test.txt we have appended some data, that is test1.txt. Let me put it like this. Okay, now if we want to see this, what is there under this test.txt. Okay, see, we have already put some data previously. Now we are going to put some data again. So this is appended now. Like previously we had only one, like some data here, but now we have appended it, and now we are able to see two like some data there. Hope you guys understood it. Is what append means in our Hadoop system or local system. Next, we'll go for creating a file with zero content. As you already know that to create a file with zero content, we were using previously touch command, touch touch. But in order to create a zero byte file in our Hadoop system, we have to use touch z command. Let me show you here, like Hadoop fs minus touch z test.txt. We are going to create a file that is called text.txt. That should be a 0 byte file. So if we are going to see whatever is the size of the file, you can see that the file size is 0 byte. This means that we are able to create a 0 byte file size into our Hadoop system using the command touchz, not only touch. Moving to some miscellaneous commands, like some of the miscellaneous commands are like you can see the cluster structure, you can see what are the available spaces, or you can see many other things like versions or something. Let me show you. Like if you want to print the Hadoop version that we are using, just write Hadoop version. That's it. So it will tell you like Hadoop version we are using is 2.7.1. That is nothing but from common jar, that is Hadoop common 2.7.1 jar. Okay, and in this system we will be going to use Hadoop 2.7.1 only in future also. Moving to next command, like if you want to see the available space or what are the total space and what is used space, we can see the same, like report the amount of space used and number and available on currently mounted system. If you put this command here, this is like Hadoop fs minus dfs hdfs colon and then slash. You can see that the cluster size is this much and we have used only this much. So the available amount of memory and size of memory is this. Like this you can find out what is the availability of cluster and all. Next we will be going to see count the number of directories, files and bytes what are the number of bytes under the path. Okay, so we are going to count the number of directives that we have created under Hadoop FS minus. Okay, so you can write either like this or maybe only Hadoop FS minus count. Like that, you will be able to know that what is the number of files, what is the number of directories, what is the number of files, and what is the size in bytes that we have used in our Hdfs system. Next is like creating a new directory named Hadoop below the user as user. Okay, as we have already seen that we have created a new directory called testing. Similarly, we are going to create Hadoop directory under that. So what we are going to write that Hadoop fs minus dir and then slash user slash sd user and then Hadoop. This means that we are going to create this Hadoop directory under Hdfs system. It's very simple. See, since we have put this command and if we are going to check whether this file has been created or not, simply put Hadoop fs minus ls. It will show that we have this Hadoop as a command that is created today, and since we have not put anything inside this, that is why it is of 0 byte size. Next, what we are going to do, we are going to just put that some of the data, okay, and we will just copy some of the data from local system and put it into Hadoop directory. Let's say we have some sample data, okay, and we are putting it into our local system, that is local system file that is called sample.txt. You can cat and you can see. See, under sample.txt we have data called sample data. Okay, now what we are going to do, we are going to copy from local and put is the same command that we have seen over there in our previous that command. We have used copy from local. So the same way we can use that put command also. This is like we are putting the sample.txt which exists in our local system into our Hadoop system, that is nothing but user as the user Hadoop that we have already created right now. And we are going to perform this query. See, now what it will do, it will just put the sample.txt data into our Hadoop directory. You can see like this. You can see as if you go user, SD user and Hadoop. Since previously it was a 0 byte file, but now if you check, it has some of the files inside it. See, now it is not 0 byte file, now it is 11 bytes file which has data of sample.txt file. And if you want to see what is the data inside it, since we already know that sample data should be the file, so we can write like Hadoop fs minus cat and then the path. We can see the same sample data same here. See, in Hadoop system also we are getting the data that is called sample data into our system. Hope you guys understood this. Next, we'll go for the next command. List the contents of this new directory. Just now I have shown you like how to list the content of this new directory. This is nothing but Hadoop fs minus ls and the path. We have only one file under it, that is called sample.txt, right? Just we have seen the same way. Next is add the entire local directory called training to the user as the user directory to Hdfs. Now what we are going to do, like we have few data in our this path, home SD user and MR data. Now we are going to put, means we are going to put some local system to our Hadoop system, and we are going to put this MR data into our Hadoop system. So let's check what is there in MR data first. Okay, we have these many you can say the data, and we can copy anything from that. So what they are asking, okay, let me put it here. See, the data under this home SD user MR data, they are going to copy it to our this Hadoop directory in Hadoop system. So if we are going to see like Hadoop fs minus ls and Hadoop, now we can see that MR data is copied. Since previously we had only sample.txt only, but now we have MR data also here, and you can see this is a directory. And if we are going to see this directory, we can find the same thing that was there in our local system. So let's check this. So you'll be able to see the same thing: courses, students, trending identified, and then trending and then trending partitioner. You will be able to see same thing. This means that we cannot only able to like we are not only able to transfer the file or put the file, but also we can put the directory from local system to our Hadoop system. Now, if we want to delete like a file called test.txt from Hadoop directory, what we should do? Like suppose we first of all we have to like copy the test1.txt file from our local system to Hadoop system, and then if we want to delete it, we can just delete like simple way only, like Hadoop fs minus rm and then slash user slash user and then Hadoop and then test1.txt. We can do the same way, or either if you are not going to follow absolute path, you can follow a relative path. Okay, so like this we can remove our directory. Next, if we go for like finally removing the entire directory of and all of its content. So the same way that I have shown you, like instead of using simply rm, we can use rm minus r. Okay, or instead of using simply not using, instead of using simple commands, we should use the command that is used for recursive thing. Okay, next we are going to see like add the text file from Hadoop directory which is present in Hdfs directory to directory temp which is present in a local directory. Okay, since we have seen putting the data from local directory to our like Hadoop system, now we are going to do it reverse. Okay, now we are going to perform the reverse operation, like putting the things from Hadoop directory to local directory. So what we are going to do, instead of copy from local, we are going to use copy to local, or instead of put, we should use get. Okay, so Hadoop fs minus get, or maybe Hadoop fs minus copy to local, this test.txt file that is already there in Hadoop system to temp folder. Okay, let us first check what is there in temp folder. Okay, the name is tmp. Okay, these many things are there, and what is going to copy? This is test.txt file should be copied. Okay, so let us copy from Hadoop to test.txt file. Since we are going to copy from Hadoop system to local system, and if you are going to perform this ls command, now you'll be able to see that test.txt here, but previously this was not there. Why? Because just now we have copied our file from Hadoop system to local system. Next, if we want to delete all the files from Hadoop directory using a wildcard, yes. What wildcard is like? We have so many things that has extension of txt and the Hadoop system, right? But if we want to delete all the like the text file, and instead of writing each name differently, we should write Hadoop fs minus rm Hadoop and then .txt. This will allow us to delete all the files that is there in txt format. Okay. What it will do, it will just delete whatever there is in as txt. So in Hadoop we had sample.txt, so it has deleted sample.txt file from that. Next we are going to see like how cp command is used, or how we can move the things from Hadoop to Hadoop only. So we can see here cp is used to copy files within directories present in Hdfs. Previously, we have seen to copy files from local to Hadoop and Hadoop to local. Now we are going to see like moving our files, like copying our files from Hadoop to Hadoop directory only. You can see like Hadoop fs minus cp user test.txt. We are going to copy this test.txt into test2.txt. Okay, so this means that these files will be copied into these files. Next is get command. As I have already told, like instead of using copy to local, we can use get command also. And instead of using copy from local, we can use put command also. So the same way it is showing there, like Hadoop fs minus get text2.txt. Okay, and where it is going to store, like this is nothing but this is our SD user, like Hdfs path, and we are going to store it into our local path, that we are going to copy it into our local path. Next, we'll be displaying like last few lines of the file called file name to standard output. This means that suppose we have some file, okay, that is named as file name, and we are going to like put it into our Hadoop system. So it is like Hadoop fs minus put file name into. If we do not give anything like after this file name, this means that it will simply take slash user slash SD user. Okay, and then we are going to like check few lines from the like end, that is we are putting tail here, so it will show us few of the lines from the end. Let us check if we have anything called file name. Okay, we have file name as these many data we have, and what we are going to do, we are just putting this file name into our Hadoop Hdfs. Okay, this file already exists. Let us see if we have this file, what is there inside this file. If you can see, if we have put Hdfs like Hadoop fs minus cat this file name, the same data is here in Hadoop also. Now what we are going to do, we are going to see the tail of this, like the last 10 lines of this file name, means from 26 to till 10 till 16. Okay, if we put like this, it will allow us to see the last few lines only. Like we have not put, yeah, this is because we have not put our condition. So if we put like we want to see only 10 lines only, so it will show only 10 lines only, or 5 lines only, or maybe 2 lines only from the end. This tail and head we have already seen, right? Next, we'll go for changing default file permission. Okay, so default file permissions are generally 666 in SDFS. Okay, but now we are going to change from 666 to 600. This means that we are going to give read and write permission to our user, but no permission, no read write execute permission to group or maybe other. So what we are going to do is like we have to change the mode from 666 to 600. Okay, so what it is doing, like it is creating a file called text4.txt, that is nothing but a 0 byte file size. Okay, and since there is nothing, it is a 0 byte file size only. If we do ls also, we'll see that the file size is 0 byte, and we can change the permission from 666 to 600 of this Hadoop directory. So if you perform this operation, you can see the permissions has been changed. Now next we'll see that if we want to set the block size to 128 MB while writing the file in SDFS, it's like we have already studied that the block size is by default it is 128 MB we are going to use. So you can set the same, like it is by this command, like Hadoop fs minus d, like we are going to set this block size, that is nothing but dfs.block size as 128 MB. This is nothing but in bytes. So if you convert 128 MB into bytes, you'll be getting this. Okay, and then we are putting this into like we will put this Hadoop file, that is nothing but a zip file, into our user as user. Then we will see that okay, the block size has been changed into 128 MB, and the same way we can change the block size to 64 MB only. The same command like Hadoop fs minus d and then 64 MB file, and then putting it into from like normal home path to our like as the user path. Next, we are going to set replication as 3. As you know, by default replication is 3. So we have to set it while configuring our file. So we are going to set as replication factor as 3 and putting the star file into this user as the user path. Next is like if we have to see the block information, we can see the block information, like which data block is present, number of blocks, size, replication, etc. We have to put fstk command, which is nothing but file system checking command. Just if we do a file system checking command, okay, and we will be going to see the block size, like number of blocks, replication factor, everything. Next, we'll see this cp command. This cp command is nothing but it is distributed copy. Okay, which is a tool used for large intra-cluster copying. We have already seen copying, copy from local, copy to local, get and put command. But if we have to like move or copy anything from one cluster to another cluster, we have to use this cp command. Okay, you can see over here like Hadoop this cp. This is our path of one cluster, and we want to move our test.txt file into some other cluster. into temp folder. Since we are using one node cluster only here, so the localhost like this is 54310 the same only. But if we have anything different also, like different clusters, we can move the files from one cluster to another cluster using this cp command. And guys, this is very important, just remember it. Okay, now we are going to see some admin command, that is nothing but how to check the cluster, what is the utility, doing all the performance testing, and then balancing loads, and then checking the health of the system and everything. See, admin commands like, see how much space this directory occupies in HDFS. If you want to see the space that this directory occupies, you just put Hadoop fs minus u minus s minus s minus Hadoop. You can see this Hadoop, that is this directory, this has occupied only 6.8 KB, like kilobytes of data, sorry, kilobytes of memory in this Hadoop system. And the same way, if you want to check the health of the health of our cluster, you can write like Hadoop fsck minus and then slash. This will allow us to like check the utility of this file system. Let me show you. So once we execute this, we will be going to check the whether our cluster is healthy or not, or whether our nodes are healthy or not. Not, it will be shown to us here only. Just wait for a moment, please. See, it is showing that our path is healthy, our cluster is healthy, and all the how many number of blocks are there, whether it is over replicated, under replicated, or mis replicated, and what is the replication factor. Since we are using one node cluster only, so we have set our replication factor as 1 only. So by this way, we can check the status as healthy or unhealthy. So right now our cluster's node is healthy. Next is run a cluster balancing utility. You have already seen that what is balancing thing that is performed by name node, that all the blocks should be balanced with the data. It's not like some block has 40% of usage and some block has 70% of usage. So you can do that balancing thing manually also, like this. Next, we are going to see like the default names of owner and group are SD user that we have already set last time. But now Hadoop use this change ownership to change owner name and group name simultaneously. Like instead of using SD user, if we want to use as Hadoop as like owner, we can perform operations like we have some of the file that is called test2.txt, and if you want to add user as SDFS instead of SD user, you can add like sudo SD user, add user and SDFS, and then change the ownership from like SD user to SDFS, like this, as we have done in our previous videos on it. Next is default name of group is Hadoop, and use change group command to change the group name. Like previously the default group name was Hadoop. Okay, now we are going to change the like group name. You can see the same like this, like Hadoop fs minus change group Hadoop test2.txt. The same way that we did in our last video, you can relate it here. Now the important thing is the default application factor to a file is 3. Okay. Now what we are going to do, use setrep command to change replication factor of a file. If you want to set replication factor of file as 12 or maybe like 500 something, so you can do the same. Like here we are setting our replication factor as 2 instead of 3. Okay, like this Hadoop fs minus setrep minus w, then 2 into any of the text file. So if we write this command, perform this operation, we can see that the like the replication factor has been changed. Next is that the replication factor is set to 2, the same way that we have done. Next is like command below using SDFS OS user to disable safe mode. Yeah, this is like you already know what safe mode is and how it is happening. Since if the cluster is down or maybe something happens to our cluster, name node goes into safe mode where it is not allowed to deal with our client that we have already discussed in our architecture part. So in order to leave that safe mode, so we need to perform operation like SDFS DFS admin minus safe mode leave. If we perform this operation, this means that now our name node is ready to interact with the client and perform all the operations. Next, we are going to see command to get our SDFS file system back to healthy state. As we have seen that it is healthy, So suppose if our clusters get shut down or maybe something happens, and first we have to allow our name node to leave this mode and go into normal mode from safe mode, and then to recover everything and to recover our data node and all the nodes to healthy position, we have to write like Hadoop name node recover force. Like we are making it manually back to healthy state. So like this way we can recover our name node. Alright, hope you guys understood this. Thank you for watching. Bye.